Hi there and welcome to this tutorial. We've been doing some promises about a tutorial regarding a clip we've posted a couple of months ago about sentence instancing. It's basically a UI where the user can type in a sentence and with the press of a button the sentence will follow the shape you've created. In this multiple part tutorial we'll show you the steps we've taken to create this tool. There are a couple of fundamental steps we need to take which are applicable for all examples. There are several ways you can instance a sentence based on mathematics, geometry and UV unwrapping. In the first part we'll show you the necessary steps for creating an input UI, how to get the right vector directions, and how to create an instancing table for replicating all the characters. Our approach relies a lot on texture instancing. This is a feature available on Kepler or newer NVIDIA GPUs. There is a workaround, but this demands a different approach, which we'll discuss in a later tutorial. Like we said, this is a multiple part tutorial. We don't know where it will end. There's a lot to explore and possibilities are endless. We start with the fundamentals. From there on, a lot of examples and techniques for optimization. Have fun! So this is our tool. Let's fill in a sentence and see what happens. So it's basically a UI with a couple of parameters. You can adjust the geometry, rotate it, change the color, the width, the height, switch between a couple of different shapes. But in this part we're going to have a closer look at this for replicating this shape, the whole UI thing. Optimization, we'll discuss that in a later part. If we have a closer look, I'm going to stop it now, and we look at it from the top. I happen to know that this shape starts right here in the middle. So if you look from it from the top, it starts here and it's following this direction. So if you imagine an X and a Y and a Z axis, this is the X, this is the Y, and from the top this would be the Z. So if it starts here, we take a closer look at the X-axis. It basically starts at 0, going to 1, -1, or 0, -1, 0 again. And if we counted it correctly, it's doing that 3 times. So if you would plot this in a graph, then this would be 1, -1. This would be time. Call this 1 seconds for now. So like we said, it started at 0, going to 1, 0, -1. So this would be 1 cycle. The second cycle and the third. Back at 0 again. So this would be the x-axis represented in the mathematical graph. So if you look at the same for the y-axis, it's basically varying in height. So if it starts from here, it's going up, down, up again. So again, 1, -1 seconds, starts at 0, 1, 0, -1, 0 again. So this for the Y, this one for the X. And if we have a closer look at the Z, maybe you've already guessed, it's basically the invert of the X pattern. And this would be -1 because it's coming towards you. If you look at it from the side. -1, 0, +1, 0 again, -1. So it starts here, 0, -1. It's one cycle, and that's 3 times. Back to 0 again, so this is the Z. And now we have a better understanding about how we could recreate this shape in mathematics. We can now hop over to Touchdesigner and see if we can replicate this one. So we're in Touchdesigner now. Let's delete the template. Press H for homing. And like I said, we're going to replicate these 3 shapes into patterns in Touchdesigner. So I'll start off with a base container. To have a clean overview, I'll call this shape snake. And to recreate these 3 shapes, I'm going to use a pattern job. And for the length, these are actually the amount of characters the sentence has. I'll take 40 for this for now. It's hard coded now, but we're going to put an expression here that basically looks at the length of the sentence and fill in the exact amount of characters in here. Like we said, this particular shape had 3 cycles. We call this one TX. Going to copy this. So you see for the X-axis, it's basically 3 cycles. We see that here as well. This one, call this one TY. And it was 1 cycle varying in height. So it's basically a sine. And if we copy this one again, we call this one TZ. And like we've seen, it was the invert of the X-axis. So instead of a sine, this would be a cosine. Like this. So I'm going to merge these 3. Merge. Close it up with a null. And the next step we're going to take is generating geometry out of these values. I happen to know that after a couple of experiments, the best way you could recreate this shape is by extracting primitive data from geometry and transferring from chops to geometry. You could use a limit sop, and you have to fill in which channels it's going to look at. So you see right here that it's already taking the shape we would like to see. And if we open up the display options and have a look at the normal directions, it's all facing upwards. And if we have a look at our shape again, it's all pointing sideways, and in the exact rotation the shape following. And if someone had recreated this with the point normals, I'll be happy to hear how, because I couldn't replicate it. I had more luck with primitives, so I would like to generate primitives in this exact pattern, and for that I used a real SOP, and a real SOP needs a couple of inputs. Start off with a real SOP. The top input is the geometry that needs to be created along the path, and I usually use a rectangle. Put it in here, and like the SOP says, like rails, you basically have to put two geometries parallel to each other where this rectangle needs to step in. And for that I'm going to merge this limit with a little brother. Merge. Well, it's not a little brother, it's basically a twin. But I have to offset it a little bit. So now it's basically laying on top of each other. And if I offset this a little bit in the y direction, like this, maybe this would already be enough. It's actually like the railway of a train walking parallel to each other. And if I put this one in here, you see that it's already generating a couple of primitives between them. And if I go to the parameters of this real SOP, I had the best luck with this parameter and this one. And if we have a look at the display options, the points again, like I said, I hadn't had any luck with point normals because this is 4 normals per primitive, and I just want to have one in the center. So if you look at the primitive normals, you see that it's already globally taking the shape we would like to see. And if we go to the roll, we can rotate it. And if I put it to -90, type it in, -90. You see that it's following the path and pointing in the right direction. So now that we have our geometry generated with a bunch of primitives and primitive normals, we can extract the data from the shape, put an out here, so we can leave our base container. Close it up with a null again. I'm going to start with a new base container. And I call this get prim data. Step in. We'll use an in to have an entrance. Connect this one here. Close it up with a null. Now we can start to extract primitive data from this geometry shape. And I start off with a table. I use exact dimensions. The rows are basically the amount of characters the shape has. And in this example, we used 40 primitives. So I don't want it to be hard-coded. So in this example, I'm going to put in expression, use op. Let's have a look at our, this is the null 1 dot num prims. So it's taking the exact amount of primitives and fills it in the row section of this table. And the data we are extracting from this null are x and y positions and x and y normals. So that's 3 and 3, so these are 6 columns. To fill in the data in these cells, I'm going to use an eval. And the eval needs an expression. I'm going to use another table for this. And again, exact dimensions, but in this situation I only need 1 row, but 6 columns for every data extraction. And again, we're going to fill in a couple of expressions. The first one would be dx position null 1 of the primitive, and that's prims, open bracket. And you can fill in a number, and so basically if you fill in the number 0, it's looking at primitive 0, and for 1 it's looking at number primitive 1. So what we could do is we can fill in the index of the rows of the table in here, and we can use the expression me.input cell.row center.x. And if we connect this one with his, you see that these value represents all the x positions of every primitive of this geometry. So we do the exact same thing for the y. The z. And for the primitive data, the normal directions, we use a different expression, and that is called normal. So you see this table is already filling up. This one again. Same thing for the y and the z. So now we have extracted all the data we need from this geometry shape. I'm going to name all the different columns using an insert dat. Fill in the contents tx space ty tz nx ny and z. And that's basically it. So I'm closing this up with a null. and then out again to leave this container. And now we can head over to the tricky part, and that's combining an input UI with this data and placing all the characters at this exact position. So we'll start up with an input UI. I'm going to use a container for this one. Call this UI. Let's get inside. Generate a field where we can actually fill in the sentence. Close it up with a null. So if we fill in something, placing that string inside of a cell, I'm going to create another base container, and in this container we're going to append this table with all the string data at the right row position, and we're going to convert the string to integers because it's a little bit easier to work with integers than strings in this situation, but you'll see why later. I'm going to call this one string convert, create an entrance for outside, place it in here, close it with a null, and we're going to start off with a clean table. And a nifty script. What we would like to have is that the string, first of all, will get in this cell, and I want every character a different column. And then we're going to transpose it so we can append it on the right here of this table. What I usually do is the table 1 I'll clear it every time it runs, because when you're filling in all kinds of different sentences every time, the script will clean this table first before it appends with new data. I'm going to define a variable called myText. It's a string, and the position is up. And we're going back a level. The container was UI, and I believe it was the first null and the first cell. So row 0, column 0. Let's check UI null 1 0 0. Okay. And in order to append the string inside this table, we're actually going to use a append function. It's called, we'll start off with the up, table 1 again, append dot append row myText. And if we run the script, we get an error. So I must have placed some kind of typo. Let's see. append row, my text, null. See, I forgot to close this one. So if we run it again, it's doing actually exactly the same thing we did in this container. And I wanted different characters for every column. So in order to generate that, we have to convert this string to a list. So define a new variable. And it's called lists, my text. And in this one, we'll fill in the list, and I call it X. So if we run this one again, you see every character now has its own cell. So now that we have converted this string with every character and every cell, I think this is a nice opportunity to make the pattern values not hard-coded anymore. So if you go back to the shape generator container, like I said, the length of this pattern is based on the amount of character this sentence has. So we can fill in an expression in here. It's going one level up. It was in the string convert container. Convert. It's called table 1. We're looking at the amount of characters, and since we've placed this one in every column, we can fill in the num calls expression. So you see this one has 9 columns, so the length of this pattern will also be 9. So we do that for the Y and the Z direction as well. You can close this one up. So now you see that this table is a lot shorter. Now we can transpose this table upways instead of sideways, but we do that later. Like we said, we need this string to be converted to integers because it's easy to work with integers in chop data than strings, and for that one we use an evaluate that. We're going to use again a nifty expression that converts strings to integers, and we do that with the function it's called ord, and just bear with me, it works. String, and looking at every cell of the data connected with it, me.input cell, and another one. So they're generating integers, and these values are ASCII values, and that's basically a language which has an integer for every string, like capital size, space, characters. Everyone has its own integer. You can look something up in Google about ASCII values, But I'm not going to get very deep inside of this theory. The thing is that these values are not starting in a very nice way from 0 to whatever the length of this sentence is. And first of all, I'm going to transpose this one. So now it's standing upwards. And if we take a select, fill in null 1, and merge this one with this column, append columns, you see that I'm going to put an insert in here to give it the column a name. We can call this one, I just call it integers for now. Column, yep. So now you see that the table is appended with integer values for every character. For the next step, I'm going to change this one-word sentence into something a bit longer. This is a test. Back to the string conversion. If I'm going to run this script, you see that everything executed just fine. But if we take a closer look at these ASCII values, you see that the letter T is 116, comes up 3 times. The space has an ASCII value of 32, comes in 3 times. And if we're going to replicate the different characters, the different images we're going to use for the instancing materials, it's not very optimized if we're going to use this table. So I'm going to adjust this script, and I need some kind of list that for every character it only shows up once. So I'm going to pick a second table. And just as the last one, I'm going to clear it first. I'm going to create a table. It's the second one. And we're going to pick the variable where the string is attached to. And we're transforming it into a different list. And this function dictionary from keys is basically looking at the entire string. And if it steps into a duplicate, it will skip that one. So we're going to transform this variable into a new list. And to generate this evaluate expression, we can also do this in this script. And we can do that by a for loop. So it's basically walking through the entire string and checks the ASCII value of this character. We can call this my character in my text. And the result will be this function we've created here. So it's that ort function which translates string values into ASCII values. My character, and in the second table we're going to append rows so we don't have to transpose it later on. I think we've have everything, so I'm going to clear this table first. I'm going to check this string, so the string this is a test, and we convert this one to a list, and we're just going to pick all the characters once, so it's going to skip the duplicates, and that's with this function. And then we're going to generate a for loop which is looking at every character and convert this with the ort function to ASCII value. So if we run the script, we get an error. I've probably missed something. Could be, yeah, this isn't right. And there it is. So you see, if you compare this table with this one, you see like the letter T, it's 116, just shows up once. And for the space value, showing up once as well. It's not in the right order, but we're going to fix that later. And there is another thing that bothers me, is that these values doesn't make sense for a replicated table. It does make sense for an ASCII table, because yeah, these are ASCII values. But I just want the first character to be 0, the second to be 1, the third to be 2. So we're going to create some kind of lookup table. And we do that by generating a base container. I call this one lookup. Going inside, pick a select that. Going back one level, that was a table 2. Yep. I'm going to sort this one first. Sort. So the space will get a 0 value. And this 33, actually don't know which. I think it's the special character. Doesn't really matter. Going to generate a different table. And I want to have the same amount of rows as this one. So I'm going to fill in exact dimensions. One column. And I believe this one is select 1 dot num rows. Yep. And to fill in these cells, which corresponds with the row number, you can also use and evaluate that. And this is just me dot input row. I'm going to merge these the merge. And we append columns. So we've basically created a lookup table that transforms all the 32s into zeros, all the 33s into ones, etc. Use an out for an exit. So now we have our lookup table. Now we're actually going to use the lookup function. Let's see, lookup. And we're going to start with, going to disconnect this one for a second. And I'm going to delete this insert as well because we do the naming of the columns at the end. So this one, I'm going to look up this table with this one. And we have to switch this one to row values. And there it is. So we see all the spaces as a value of 0. The T value of 7. So if the replicator comes at the 7th replicated character, it's going to fill in a T. We can append this one maybe for more clear overview purposes. Going to transpose this one vertical again. So we're going to merge this one with this table. Oh, I need a merge. Append columns. You see that the letter T has 7, the spaces 0. So with this table we're already heading towards the replicated table as it needs to be. But in this particular example there are still duplicates. So we're going to use this table for the actual instancing table. But for the replicator table we need a different one. So what we're going to do is we can convert this one to characters again. And instead of ort, we use a different function, which goes the other way around. chr me.input cell. So you see these values are now correspondent with the ASCII values. I think I'm going to finish the instancing table first before I'm going to create the replicated table. So we have these values. going to use an insert. We can call the first column ASCII. No, you write it different, of course. And the second one, we can call that one integers. And the third one, characters. Close it up with a null. We can merge this table append columns. Let's see if it actually somehow disappeared. That's weird. Oh, there they are. So you see we've appended this table with all the positioning value, all the normal values, with character values and integers. So our instancing table is finished now. But for the replicated table, I'll call this one instance. And we use an out. The replicated table is a little bit different because we're going to erase all the duplicates. So this table will be our starting point. So again, we need a lookup. This one goes in the first, this one in the second. Use row values. So you see these are corresponding with the lookup table. And if we're going to merge this one with this one, append columns, we're going to sort this. Yeah, it already did. And this is actually the replicator table as we need it. So it's iterating through this table, the replicator component. And the first one will be empty, so that will be the space value. This special character will be the second one. So we basically only need this one and this one, but we'll leave that one here for now. So close it up with a null. Call this one replicator. And use an out as well. So now we have two tables. One for the replicator and one for the geo component with all the positioning data for every instance. So the next step will be actually generating all the instances and setting up the Replicator table or the Replicator component which creates all the images. So now that we've done our primitive conversion and our string conversion, we're going to start with replicating all the images which we're going to use for all the materials, textures for all the different instances. So we created 2 different outs. The first one is for the instancing instance, and the second one for the replicator. So we'll start replicating the images based on the text, and we're going to create a different base container. We can call this one characters. And inside of this, I'm going to use the replicator. And we're going to replicate a texture. It will be in text. Start with 0. And the content of the text, we're going to fill in an expression which is going to look at the replicator table and going to look at the row based on the digits of this texture top. And we do that by going up 1 level. This was called Replicator me.digits, which will be the first row, because the digits of this text top is 0. And it's going to look at the, I believe it's the second one, or the third. Yes, the third column. No, the second. 0, 1, 2. 2. Close it. This is some kind of glitch. I'm in build. Let's see. 20,000. I believe they fixed it. But if you see this glitch, you can switch this display method to bitmap, and then it's gone. I believe in the later builds they fixed that. So now we're going to replicate this one. We're looking at the operator text. The master operator will be text 0. We're going to replicate by table, and the table will be the replicator. So you see that I'm going to adjust it a little bit to the side. Now you see that this replicator generated all the images we need. And if we're going to change something in here, like the font size, let's see, make a little bit bigger. I believe there was a function where you can fill the entire. Well, let's see what this does. So it's a little bit bigger. Auto fit, yeah, that's what I needed. But it's not working at the bitmap display method. Stroke, polygon, no, automatic, bitmap. Well, it doesn't really matter. I believe if you use automatic, you can use auto fit. If you're going to re-replicate this, see they are much bigger. But with this specific build, I have this weird glitch, so I have to switch it to bitmap anyway. So I'm gonna recreate this. Just play with it. Maybe 100. Yeah, okay, this will do the trick. Okay, that's done. Before we're going to actually instance all the geometry, we're first going to convert this table dat into chops. And the reason why is that we're going to manipulate these position values in a later tutorial. And if you're going to instance the geometry based on a table dat, it can get a little bit heavy. So if we do adjustment in the chop world, it's much lighter. So after we've done all the conversions of the primitive data, we just can close this chapter up, and we're going to convert this instancing table into chops. And just like with the characters, I'm making a different base container. Call this one convert chop. So let's get the data of our table. Select upper level. And it was called instance. So there we are again. Close it up with a null. I'm going to convert this one to chops. Dat to chop. And we're going to output it channel per column. And I want the first row to be names. Yeah, so you see that we've got all the positioning data and also the integer data for all the characters. We're going to pick from the replicator textures. I think we can already generate our model based on this table or these chop values. So close it up with a null, use an exit. So there it is, null again. And if we're going to create a rectangle for geometry, rectangle into a geometry component, and we'll fix up our render setup. So we need a render top and a camera. like this. Now we're going to instance our geometry based on this job data. So we're going to the instance tab, switch it on, pick null 3. This will be tytz. Somehow missed the tx. Let's see what happened. I think I made a mistake with the conversions to chop. That to first column is values. Yep, there it is. So now we can pick our tx, our ty, our tz. So you see it's already starting to get the shape where we started with. In the second tab, I'm going to rotate to vector, the nx, the ny, and the nz. So you see it's already starting to follow the shape we've created. But it's not, because the sentence is very short. We can try to make it a little bit longer. So we'll go into our UI component. Make the sentences a little bit longer. This is a test to see if the shape is working, etc. We can copy this one a bunch of times. So it's actually a lot longer. And if you run this script over here, everything is adjusting. And you see it's already much bigger. When in this case the geometry of the rectangle is a little bit too big. So make this a little bit smaller. I think this will work. Yep. But they're all black. And you want characters at every position. So what we're going to do is we're going to create a material. And I'm going to use a phone. I think I'm going to emit this one white. So we don't need a light source. So there they are. Nicely following the curve. And in order to give every instance a different texture based on our replicator table, we're going to this instance texture field. Like we mentioned earlier, you need one of the newer GPUs, an NVIDIA or something recently will do the trick. If you have an older system, probably won't work, but you'll see it for yourself. In this geo component, I'm going to have a look inside of the character, if I'm not mistaken. Characters. And we're going to look at the texture. Text. Asterisk. And this, instead of this asterisk, we're going to look at the job value. And that one was called integers. So now if you have a closer look, you see that it's already filled in all the different characters. Going to adjust the render settings a little bit different. Set it in portrait mode. Adjust the camera a little bit closer. Maybe rotate it a little bit. I'm going to use this trick to set the pivot point always at the center. Minus me.par.ty minus me.par.tz. So if I'm going to rotate, it's always keeping the geometry in the center. I think I'm going to make the rectangle a little bit bigger. And you see that the rectangles are overlapping. And you can fix this with setting the transparency to alpha to coverage. And there we already have our sentence instance based on a shape we've created on mathematical principles. I think if I'm going to flip this one, transform the Y. Yeah. So now we're not looking at the back of the textures. The next step will be to move this shape, and then we have to get back to job data. So we're going to need to isolate all the channels, extend them in some kind of cycle loop, and use some kind of incrementing value to let the shape animate. And for that we're going to use a select first. That too. Or no, we're just going to use the null. Better. Channel names TX. So there's the shape again. I'm going to copy this one a couple of times. We had 6 position data. 3 positions and 3 normals. So we're going to copy this one 6 times. 5, 6. This one will be TY, TZ, NX, normal Y, and normal Z. I'm going to extend all the patterns. Extend. Because this one just stops right here. You won't get a very nice animation. So we're going to give this one a cycle behavior. So you see that it's starting the cycle back from here. So if we're going to shift this pattern, it's going to follow along the shape in a loop. And we're going to basically do this for every position in data. So we can copy this one 6 times again. In here. You probably think, why aren't you going to merge all these ones and do the cycle just one more time? We're going to manipulate all the positioning data in a later tutorial. So separating or isolating all the different channels comes in handy for the future. So bear with me. It's going to be a lot of fun to actually move this loop. We're going to use a shift, and I think if we are going to adjust this, you see that it's moving, and that's exactly what we need. So again, for all the positioning data, we are creating a shift. And just close it up with a null. I believe the shortcut was Alt-N. Yeah. I don't know why it's making that sound, but it's a handy shortcut to know. We're going to animate this scroll offset, and we can do that with a speed job, and we can use a constant to drive the speed job, otherwise it will just keep still like this. So if you put a value in here like 1, see that it's actually moving, and the offset doesn't. Yeah, we're going the other way around. So if you see, if we're going in the positive direction, because we had a loop behavior on the left side, and it won't loop, so we're going in the negative direction. So we just fill in -1. It's no big deal. -1. So it's going the other way around. Just reset it. Close it with a null. And we're just going to export all this data to the scroll offset reference. You see that it's moving very slowly. If you adjust its value like -10, see it's going a little bit faster now. I think for this purpose this will do the trick. We're going to append this job data with our new data. So we're going to use a merge. And we're going to set this one to keep the last, because it already has a TX. And when we plug in a new TX value, it's going to keep this last one. And since we're not going to adjust the ASCII value and integers value, those are just going to be as they are. So if we connect this one in here, there it is. It was quite a technical tutorial, but this is the basis for our texture instancing tool. Let's see if we can give this one a white background, like in the example. We'll use an over and a constant white background with the same resolution data as the render. I can do a hard coded now, but it's nicer if you make an expression in here for the future, but you won't see anything because the textures are also white. So if we're going to emit black, you see that it's already working. Maybe make this one a little bit bigger. Make it a little bit slower. Just change this one to something like -5. See that it's going much slower now. So yeah, that's basically the basis of our multiple part tutorial. Like we said, we don't know where it's going to end because these couple of converts are very powerful for creating these kind of animations. We hope you've enjoyed this tutorial and are looking forward to the upcoming parts of this sentence instancing series. Please like and subscribe for support. This will help us a lot for boosting our motivation. If you find the time, have a quick look at our Patreon site, where you can find the work files of our tutorials, a couple of 3D models we've recently modeled, and it's our intention to keep the updates steady and rich. For now, thanks for watching, and we'll catch up next time.